Well, good afternoon. My name is Kimberly Tripp. I've been working with SQL Server for a long time. For the last 10 years, I've been doing training, consulting, speaking at conferences, working on a lot of different resources, white papers, various webcasts. In fact, there's a couple of webcasts that I did on SQL 2000 defrag. And since it has changed the most between 2000 and 2005, for those of you who want to know the right way to implement the strategies I recommend today in 2000, I'd recommend the webcast because I'm going to focus on a lot of the new ways to implement and defrag your objects in 2005. So the first bullet there, everything is about availability. Why did I start with that? I know this is a session on defrag. I know we're going to talk about how your tables and indexes become fragmented. But part of the reason why this is so important, especially historically and even especially in 2005 because of the new features, everything in terms of why you want to minimize the fragmentation that occurs is related to keeping your tables more available. A lot of people have heard that SQL 2005 supports an online defrag capability where you can defrag your tables while users still continue to use them. And while that's true, you can. There are some criteria that you have to meet in order for that to be true. So it's really important to kind of know that it's not just a given that everything will be rebuilt online. Meaning, when you defrag, you might impact your table's performance and availability when you defrag. So you have to be thinking in terms of availability. And there's actually a variety of different topics that are related to availability. So everything is kind of tied to, in terms of, especially my next few sessions, availability of SQL Server. So I want to do a little bit of a quick overview on availability and the impact that you might have. Then talk about fragmentation, what the ways are that you can see that you have fragmentation, which are very different in 2005, how to minimize fragmentation, which you can use the old ways that you had in 2000, but there are new and better ways of minimizing that fragmentation and defragging in 2005. And then we'll talk a little bit about automation, as well as understanding query usage, index usage, and performance. There's some new features that I'm going to have to talk about throughout the session that by the end of the session I'll want to give you some more insight into. So, availability. Just a quick one slide here on availability. From an availability perspective, if you are looking at hardware failures, right, there's lots of features that are going to end up minimizing the impact to availability and reducing the amount of downtime. So that's one aspect. So we always tend to think of availability, like whenever I ask somebody, what would you think of for SQL Server's availability story? I almost always get clustering, right? What is going to improve availability? There's actually a whole bunch of other options that can help minimize the impact to availability and the downtime through some form of technology and redundancy. Then there's human error, which is really challenging to end up recovering from in some cases. I'm actually going to talk about database snapshots and the different backup types of strategies and partitioning strategies that can help improve availability in my session tomorrow on VLDB availability. But even if you put all of that technology into place, and that's the reason for this session, even if you put all of that technology into place, if you've got a great highly available solution that every night you take tables offline to end up rebuilding the tables, then you're kind of missing the point in that, yeah, the database server is available and online, but the users can't get done what they need to get done when they need to do it because the table is in fact offline. So you have to think of availability from a really wide range of features, capabilities, and impacts to your user objects. So this is going to be something that's really going to help improve your availability, especially with some of the new features in SQL 2005. So online index rebuilds is one of those. And I'll show you when that can take effect and when it doesn't. So we'll start here. What is fragmentation? You know, I kind of make the comment occasionally, this job would be great if it weren't for the users, right? If there were inserts, updates, and deletes, or if there were none, right, then we wouldn't have any form of change. If we didn't have any form of change, then the data wouldn't become fragmented. So really the answer to the question of how does fragmentation occur is very simple. Change to the data very likely is going to result in record relocation and something called a split. So I'm going to show you when each one of those things occurs and what its side effect and impact is against that particular table. So the way I think about this is really there's two types of structures that can be fragmented. There is a clustered structure, which is really the table itself. If the table is clustered, then the table's order is defined by that clustering key. Non-clustered indexes are just like indexes in the back of a book, so they have information that's duplicated. All of those structures, the base structure, which is the largest structure, and all of these secondary structures can become fragmented if data modifications occur. So we have to take a step back, understanding the structures, and say, when would each of these different types of modifications cause some form of fragmentation? So if we think of an insert, into a table, and then we think of how the table is structured, if the inserts are going all through the table, that's possibly going to require lots of new free space. So that's going to possibly cause a lot of fragmentation. But if all of the inserts are going to the end, they're isolated, then we probably won't have as much fragmentation. At least not fragmentation due to inserts. But then there's updates. If the data changes and the row size changes, the row may no longer fit on the page that it currently resides on, and we might have to relocate it. So that's going to cause fragmentation. But updates, you're not usually changing that much of the row, and if it's a fixed width column, you're not going to change the row size at all. So you have to take a step back on updates and say, well, it's not just an update. It's an update to a variable width column that makes that variable width column significantly larger, because smaller is not going to cause you grief. So only when a variable width column is made larger might it cause a split. So updates aren't as big of a concern, but they're certainly a concern. And then deletes. Deletes aren't really that big of a concern. And let me explain why, because I've been called on having said just what I said. What do you mean deletes aren't that big of a concern? When I'm doing deletes of 75% of my table, the deletes are taking, hours against that data set. And this was specifically something somebody said to me. They said, you know what? You said deletes weren't that big of a concern. And I was like, okay. And they said, but I had a clustered table, and you recommend a clustered table. And I said, yes, I do. And they said, when I dropped that clustered index, my delete went from 22 minutes down to 2. And I said, well, you're not telling me the full picture. Yes, I am. I said, no, actually you're not. And it was quite funny. I said, you had to have non-clustered indexes. And you know what I ended up doing? I ended up creating a blog entry that is by far one of the biggest blog entries that I did. And it's kind of an interesting one to read if you're interested. It's related directly to this question. When you have a delete against a table, and let's say the table is ordered for the delete, it's date-related deletes. So the table is ordered January, February, If you delete a large range of data, all of those pages get deallocated. It's not a big deal at all, okay? But you know where it's a big deal? Is not the table, but all of those indexes that look up into that data. You're deleting a range of all of the January, February data, but when you go into an index that's ordered by customer number, where are the customer numbers for customers that placed orders in January and February? They're all throughout all those non-clustered indexes. There's a really long blog entry that kind of proves the point that it wasn't just going from a cluster to a heap that was, in fact, what caused them major grief. I will tell you that non-clustered indexes on really large data sets that have a consistent pattern of manipulation are always going to be slow. So then I always get this question, what can I do to improve that? Partitioning, okay? I'm not going to talk directly to partitioning in this section or this session. I will tomorrow in the VLDB availability strategies. What I'm going to look at is taking January, February, March, April, sectioning that off in such a way that I can deal with the partitions individually, deleting large chunks of data without negatively impacting the table. So I want to stress something about large range manipulation against a data set. While I'm saying that deletes don't cause you major grief in terms of fragmentation, which is true, because if it's a range delete, they're just going to clean up. If they're singleton deletes, then they will reuse that space later for inserts and updates. So it's not causing you major grief because rows aren't being relocated. But it will cause you major grief if you're doing large-scale range deletes and you have lots of other indexes. So that's where things like partitioning comes in. So there's a logical progression of the things that you can do from a design perspective on larger tables. So on most tables, though, deletes in and of themselves don't cause you as much grief. Now, Non-clustered indexes are rarely ordered by something that is ever increasing. So in a lot of cases, your non-clustered indexes are going to become very fragmented very quickly. The good news is that a non-clustered index is relatively narrow. It's going to be easier to keep these more compact, and it's going to be easier to manage and defrag these with a lot less impact to the system. So the two types of structures are very different in terms of what their costs are in terms of maintenance. So we have to think about them separately. So again, now taking a step back, I did clustered and non-clustered, but then we just look at the individual statements. And it really is the same concept, I just want to look at it a different approach. So inserts, right, in the clustered structure, since it's the whole data row that's going to be inserted, that's much more likely to cause a split. But in a non-clustered index, it's just the non-clustered index information that gets inserted. There's not as much space that's required to do that, so that is not as likely to cause as much fragmentation, and you'll end up finding that once it does make room, there's a lot of room that's available so that splits don't keep occurring after that. So you have to think of each of the individual statements and what their impact is to the base or leaf structure of the index. That's where one entry for every row resides. So now, let's look at it physically. What does fragmentation actually look like? What I've drawn at the very bottom here is a leaf level of an index. I'm not saying necessarily that it's a clustered index or a non-clustered. It's almost irrelevant. An insert that occurs to the table is going to have to insert a value into every index, right? Every insert impacts every index. Every delete impacts every index. So on an insert, we have to take the row, go to that particular index, and insert whatever information we need to put into that index for that insert. So if I have data ordered for this particular index by name, so this could be a clustered index by name, even though I don't generally recommend that, could be a non-clustered index by name. So we go ahead and insert a row called a tassel, and we need to put that onto a page that has room for a tassel, actually, which is this second page, right? And there's actually no room to fit it, but it has to go there alphabetically. So this could be an insert to a page which is full. This could also be an update to a page which is full. It doesn't matter. The process of how SQL Server makes room is the same. And that process takes a few steps. The general process is they link in a new page. Somewhere else, probably already allocated to this object, but maybe nowhere near the page that needs room. So they might go and allocate a page that's way over here. And the way that they link that page in is they end up taking 50% of the data that's on the page that's being split. They split it 50-50. They take that other 50% and they put it over on this newly linked in page. So the 50% that was there goes to this newly linked in page. But that's where things really get interesting, because we have to make sure that the doubly linked list is maintained and is up to date. So now the data goes some A's, some more A's, then we go way over here for A's, and then we come back for B's, C's, D's. And the more that this keeps happening, the more fragmented this data becomes. So this is fragmentation, right? This is fragmentation in the leaf level of an index. Every index is prone to fragmentation. So now, there's really different types of fragmentation. So let's define it more thoroughly. There's really two types of fragmentation. There's something called internal fragmentation, and then there's something called external fragmentation. Internal fragmentation, the connotation of fragmentation, everybody thinks is always bad. It's not always true, right? If you think about it, having a little bit of free space on the pages means that we're not as likely to split. And that's what internal fragmentation means. Let's have a little bit of free space on the pages. But if we have internal fragmentation as the result of splits, they're 50-50 splits, so now we have just a huge amount of space on all of those pages. So internal fragmentation can be good if it's not too much space for OLTP, and it definitely is bad if there's too much space for analysis. Because analysis, if we have to read those pages, and those pages have gaps, then, and a lot of people say to me, yeah, but that's just disk space, who cares? When a page is read into memory, it's the entire page. So if you're wasting 50% of your page on disk, you're wasting 50% of your page in memory. And if you have a tremendously fragmented table, an extremely large and tremendously fragmented table, you could end up wasting, half of your memory because of fragmentation. And we always talk about how to improve performance. We talked about security today. I don't know how many of you were in there, but we always talk about trade-offs, and we always talk about security being expensive. It amazes me though that if there's a little bit more effort put into some of these things in terms of tuning, you could end up putting more security in place with a little bit of that tuning and probably still have better performance, right? You need to kind of look at the overall picture and get some really good insight into what's going to give you the biggest bang for the buck. And this is one of those things that's very easy to manage programmatically, right? Very easy to proactively prevent in a lot of cases, right? And you can very easily automate the cleanup of this. So, very easy to get good performance if you know that this is happening. So that's the bad news. I usually find out that people have fragmentation because performance is bad and they don't necessarily know why. And often it relates back to, well, how do we know that our tables are fragmented? So internal isn't necessarily a bad thing. So internal means that there's space. Too much space is bad, not enough is bad. But finding that right balance is important. Now, external fragmentation is that left to right order is no longer physical. It's logical. It's always maintained logically. They always have a logically maintained doubly linked list, right? So A's, then B's, then C's, then D's, then E's. They will know how to traverse that doubly linked list. However, the data may no longer be physically A, B, C, D. It's logically intact, but not physically. This, to me, is always a concern. And it's always a concern because not just because all the left to right order is out of whack, because once it's into memory, we're not hitting the disk, right? So it's not as big of a concern. But it implies if you have a left to right externally fragmented table, you also have an internally fragmented table because the only way this could have happened is through splits. So when I see a lot of external fragmentation, I will always go back and say, okay, I know I probably also have internal fragmentation. How can I minimize external with a reasonable amount, proactively, of internal? So I actually create tables that are internally fragmented to minimize the potential for external fragmentation. And it's very easy to do, to be honest. So how do you know? It could be more disk access. It could be that you are basically not effectively using memory, so you're going back to disk, you're getting more IOs for the query. Maybe users are starting to tell you, it seems to have gotten slower and slower and slower in the first couple of months that it's been in production, right? So you start to see degrading performance over time. So cache utilization, or you're watching IOs, or how about you just look, okay? That's probably the easiest. There is a way that you can see fragmentation. Now, in SQL 2000, the way to see fragmentation was with the command called dbcc show config. Not the most obvious, but okay, show me the contiguousness of the table. Okay, but dbcc, right? The database consistency checker, show me fragmentation, basically. I don't know, it didn't necessarily make sense. And in fact, how many of you have used dbcc show config? Oh, awesome, okay. So how many of you are totally irritated with the fact that even though it supports table results, which is great, how do you put that data into a table? Yeah, some of you are laughing, right? You have to pre-create a table, then you have to use insert with dynamic string execution to actually populate the tabular data set into a table, then you get to walk it, right? And a lot of you are kind of going, oh, okay, that's how you can do that. Some of you may not have ever even done that. It's non-trivial. It's not real, directly obvious or intuitive. What they've done, and at first glance this may not look very obvious or intuitive either, but they've created a series of what are called DMVs, Dynamic Management Views. Now, not maybe real obvious in what that is yet, but a DMV, a management view, is a view that gives you insight into some aspect of the server, and there's something like 87 of these now in SQL 2005 IDW 15. They've actually increased slowly version to version. And the DMV that gives us information about scan density and fragmentation of a table is called DMDB index physical stats. Now, a lot of people then go, these look awful. They've actually got a really good naming convention and strategy to them. They're all DM underscore. Okay? Then all the DB related ones, the database level ones are database, and then all the index related ones have index, and then there's 3 or 4 index ones. Index physical stats, index operational stats, index usage stats. So there are DMVs that can give you insight into what your system looks like and how your system is even running. And what's cool about a view? How do you put data from a view into a table? Oh, this is a trivial. I'm actually looking for the simplest answer you can give me. If you have a view and you want to copy some data from a view into a table, what would you use? The easiest way to do it. Select into. Absolutely. You don't even have to know the structure of the table. Right? With DBCC show config table results, you had to pre-create a structure and know what the resulting structure was from DBCC show config with table results, which is probably where some of you may have given up. But if you can say select star from a DMV into your own table, you literally don't need to know anything about the resulting structure from that DMV to do that. So now the manipulation and usage with these new objects is way easier, and to be really honest, the information they return is much better. They give you a lot more detail. I get this question a lot. How do I see the fragmentation in my B tree structure? Well, DBCC show config doesn't tell you. If you use one of the options for DMDB index physical stats that will give you a detailed view, you'll actually get the entire tree structure and fragmentation at every level. So there's multiple modes and ways you can run this. I'm going to tell you a lot more about that. But you can see fragmentation directly by asking. So now just to kind of summarize this again, show config in 2000, it was messy. In 2005, even though the naming conventions are kind of ugly, the first time I went, what is it again? It's DM, DB, index, physical. I got used to it, right? Now they all are fairly clearly obvious. There's DM exec, DM, DB index, DM, DB, there's just a ton. And I'll show you actually how you can interrogate the system to find out what they all are as well. And then I wrote some really nice functions to help you see more details about these as well. So detecting fragmentation, I really do like the DMVs. And I'm going to show you some ways that you can get some really good info out of the DMVs. And to be honest, they're not overly well docked. So I think you'll end up using these functions I'm going to create pretty consistently. But for 2000, if you are interested, because I'm not going to do demos with DBCC show config, you may want to check out the webcast. So I just wanted to put in that resource link for you. For 2005, we're going to use the DM DB index physical stats. And what this, again, is a dynamic management view that tells us about the physical structure of our indexes based on the parameters that we pass in. So when we say it's a DMV, right, a dynamic management view, view kind of implies pretty simple, straightforward view of the data. But these also include functions that yield a tabular data set. So it turns out that some DMVs are truly a view with no input parameters. But some DMVs are actually inline table valued functions that produce a tabular data set and have required input parameters. So again, I've got some good functions that will help you start to interrogate which is which and what the input parameters are. But it turns out that using my functions, I kind of reverse engineered a lot of this because, again, in earlier builds, some of the stuff wasn't overly well documented at all. It's gotten a lot better. 15 is actually pretty good. So the June CTP of SQL 2005 has quite a bit of good documentation on the DMVs, including the DMDB index physical stats. But there's 5 parameters to this DMV. The first one is the database in which you want to check fragmentation. In and of itself, that should make some of you pleased. You can run this DMV across your entire server and end up getting information about fragmentation of every table in every database with one command. I get this question a lot. How do I switch programmatically from database to database to database to database to run DBCC show config? Now, if you have 10 but fairly small databases, you can use this one statement to essentially materialize the DB index physical stat information across all 10 of the databases and put it into a table. Now, if you have larger databases, I don't think I would actually do that if I were you. But you could. You could. You can also put in a specific table, a specific index for that specific table, and if the table is a partition table and you just want to see the fragmentation of one of the particular partitions, you can say, I just want to see partition number 4, and then you state what level of depth and detail you want to see about the fragmentation. So what I did is I documented this for you guys. You can put in database ID of null, and you know what I did that's even more helpful? I ended up basically doing every possible combination of the different parameters to make sure that I knew exactly what this was going to return. So, because I apparently have too much spare time. So, but select star from sysdmdb index physical stats, and I basically put in null across the entire board. Now, I could do this across my server. Probably not the wisest of decisions for me to do this, because I do have some databases that are a few gig, which isn't huge, but on a laptop with just me, not maybe the best decision. But this will go across all base objects, all databases, so not all indexes. If you want all base objects, but only in a specified database, you can be in master, but end up going and doing this just for the credit database. Now, my credit database does have a couple of objects that are literally a few million rows, but you'll notice this came back fairly quickly. In fact, maybe I should go back and see how long this takes. Still running, still running. I've got the little world turning down here, and it's actually pretty impressive, because the default mode in which this runs is actually a very limited, lightweight type of scan. So it is taking a few seconds, but across, I don't even know how many databases I have here, across, well, 639 individual base objects, it generated the fragmentation in 16 seconds. So it's not a huge amount of objects, but it is a few gig that it just went over. And the reason that it can do this so quickly is that the default behavior for the mode is very similar to the DBCC show config with fast. It doesn't tell me internal fragmentation. It solely tells me external fragmentation. So it's a lightweight scan of the objects without doing individual page calculations to calculate free space. Right? So it's very lightweight, very easy. So it's actually not too bad to run it in some cases across your entire server. I'm not going to strongly suggest that, but in some cases that might be really useful and very easy for you guys to do. So you might want to go specifically to a database. Right? You might want to take all the defaults. It turns out that the defaults are the same as null, so that's not going to be that different. You can also put in a database name and then specifically request a particular object from that database. But you know what I found out in playing with this and really messing with this is that if you're not in the database credit and you want to do just one object's level of fragmentation from master of an object that's in credit, you need to specifically and 3-part qualify the entire table name. So it's a good point to make that if you want to do this, you have to have this specific combination. If you don't, it'll end up, I believe, generating, well, let's run it real quick. It'll generate a null, and then it'll end up running across the whole database. And I know the first couple of times I ran into that, I'm like, but I only want the charge table. Let's see what we get. Okay. Now the charge table is 1.6 million rows. Okay. Database, look at my object IDs. They differ. These are different objects. So clearly, it's not just the charge object. But if I go back and I put in the fully qualified, and that's a little misleading, isn't it? Wouldn't you have almost expected like an error or something like that? It's really straightforward what it's doing, and it's obvious once you see it the first time and kind of get it. But I looked at it for a few minutes. I'm like, this looks fine. What is it doing? They're doing object ID of that object, and the object ID of that object in master is null. So the end result is that they're saying, for database credit, null, 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 detailed. Right? So that's what's ending up happening. If I put in the 3-part naming for object ID, I'm getting the real object ID of that object within charge, or within credit for the charge object, so it just gives me that. And I'll show you if I run that, I'm really getting just that particular object ID. Okay, so I played with this a lot. I'm not going to go through every one of these, but I did put this into a script where you could really walk through and see all of these if you're interested. So sys dmdb index physical stats has a variety of different ways you can run it. So now let's start looking at the differences in the ways that you run it, and then I'll show you some more examples. So database ID is a nice parameter to this. You can run it across all databases or specifically in one. You can run it against a specific object or all objects, and then you can say which index or all indexes that you want to see that information for. Okay. Partition number, I mentioned, if you have a partitioned object, you can see the fragmentation just for that partition. And then mode. Mode is the most important. There's 3 levels for mode. The default mode is what we call limited. And the limited mode is saying, I just want to quickly find out if the leaf level has external fragmentation. That's all it's doing. Leaf level only. Just external fragmentation, just telling me if the left to right order is not physically left to right, only logically. It's always logically left to right, right? But physically left to right. So I can get that from the limited scan. And does not give me any information about the internal fragmentation. Now sampled, they didn't have anything like this in 2000. Sampled is a totally new concept and mode. And the idea of sampled is that they will go against the table and not get every page read unless the table's fairly small. If the table's under 80 meg, they will do a complete scan of the table. But if the table is more than 80 meg, 10,000 pages, so if it's more than 10,000 pages, then they will actually read 1% and 2% of the data and compare the discrepancies between those 2 percentages. And if there's vastly different percentages of fragmentation, they'll go as much as 10% of your table to try to come up with a reasonable sample average without reading the whole table. So this can tell you that you have some fragmentation, but it might not really be good in giving you full detail. But the benefit is it puts an intent shared lock on the table, not a shared lock on the table. And an intent shared, that's the IS lock that I start with there. The IS lock says that there can be readers and there can be, and this is a common misconception, there can be readers and there can be writers on this table. This is a non-blocking read type of lock. Now let me give you a little bit more detail. What does it block? It would block a schema modification, which you shouldn't really be changing your schema all that often, or some form of exclusive table level lock, which would be an insert, update, or delete that has absolutely no, well, an update or a delete that has absolutely no where clause. And again, these in most production environments are not all that common. So my point is that these are both non-blocking ways of seeing either just the external or the external with averages for your internal. And that's what sample does. Now, if you have some time and you don't really care about possibly blocking your writers, which I realize some of you laughed, some of you don't have this option, okay? If you're 24/7, 365, there's no way you would ever want to do this unless you back up and restore. Fragmentation in the source database is restored exactly the way it is fragmented in the source database when you restore it to a destination. Okay, there's no defragging that occurs. So some of you might benefit quite a bit by taking a database, doing a backup, restoring it to an alternate environment, and doing your contiguousness checks or your fragmentation checks against that secondary database. Because if you have fragmentation and you want to get a really detailed, thorough report, fragmentation is going to be the same as it is in that production environment. But this does put a shared table level lock, which does, in fact, prevent writers, but it still allows readers. So this might be acceptable for some of you. But the best part about detailed is that it will give you the fragmentation at every single level of your index. So going back over here, if I go to a table like charge, because again, my charge table is 1.6 million rows. It's not huge. I didn't want to sit, 5 minutes between each one of these executions. So 1.6 million rows is still enough to start seeing some interesting values. But select star from the DMDB index physical stats for the database, which is current. So in this particular case, a little bit earlier, I did a use credit. So all of these down in here are just grabbing the database ID for the current database. So let me switch over to credit so that I get the same scenario that I had here. And if I say that I just want the charge object with a limited scan, then the limited scan is fairly quickly, oh, actually, excellent. I forgot about this, but this is great to show you because you'll run into this. And I don't know about you, but how many of you know the problem right away for this one? Now, some of you have been working with the betas. You might know this one right away. My database compatibility mode isn't right. See? Because it tells me that right there. Right? Database compatibility mode is not correct. Oh, okay. So I must change my database compatibility mode. And I think I have that somewhere in here. I'm almost positive I do, but I might have it in a different script. So it's probably good to note here. If your database compatibility mode, SPDB CMPT level, because it's very obvious, I don't know why I'd forget that, credit. So if I ask for the database compatibility mode for credit, it'll tell me that my compatibility mode is 80, which is SQL 2000. So if I change this instead to 90, which changing database compatibility mode is a very quick, very fast type of step because nothing really changes. All it does is it says invalidate all plans so that everything will get recompiled, and everything will get recompiled as if you were a parser for SQL 2005 for version 90. So it's really more of a parsing, keywords, reserved words, making sure that you fall in line with all of the new features for 2005. And one of the things that is impacted are the DMVs. Many DMVs generate that syntax error literally just for having the database compatibility mode to be SQL 2000. So what I have now, so which one did I do? I did the charge object, no specific index, so just the base object, no specific partition, so all of the partitions, but it's not a partitioned object, and then limited. So I just want to see the fragmentation for this particular object. So there are my base objects, my indexes. One, the index ID 1 is always the clustered. Index IDs of anything greater than 1 are going to be non-clustered. So if your table has a clustered index, index ID 1 is the clustered. And you no longer have to know all that gobbledygook because they actually give you detail. In a lot of cases, in almost all of these tables, there's like an ID and then a description. An ID and a description, and an ID and a description. And I'm really quite pleased with that. Across almost all the DMVs, I don't necessarily have to know all those little internals anymore. A lot of us that used sys indexes, right, had to remember all the different index IDs and all the types and how that worked, and nice that they've got the description here. Now, I haven't told you this yet. There are actually 3 types of structures in your tables in SQL 2005. I'm really only talking about something called in-row data so far, meaning for your data rows that are under 8K in size, yes, you can have rows that are over 8K in size in SQL 2005. So for your data rows that are under 8K in size, they will be stored pretty much identically to the way that data was stored in SQL 2000. The base structure has all those data rows, and rows cannot, if they're under 8K, span pages. But they have a new concept. You can have a data row that has, let's say, 2 varchar 8000s, and each one can be filled 6,000 bytes. You couldn't do that before. What ends up happening when a row goes larger than 8K is that they will create a very special page for that particular table called a row overflow page. And they will end up having some of the data on the original and some of the data on the overflow. But that only happens for the varchars that are under 8K but make the row over 8K. There's a third type for every table, and we had this in 2000. The lob types, right? The lob types are the text, image, end text, and the var binary types. Okay, so those are all stored with your lob types when they are the large object types. So there's now 3 base structures. So what you're seeing when you're doing this DMDB index physical stats is you're seeing the in-row data structures. So what does that in-row data look like? Well, the index is 3 levels deep. Okay. Get some really nice information about whether or not I have fragmentation, how many fragments I have. That's not looking very good. Okay, I literally have 3,000 fragments to one of my indexes, and each fragment size is roughly 1.47 pages. So it turns out that I have like a little bit, like 1.5 pages, and then the next page is somewhere else. And then I have another fragment and another fragment and another fragment and another fragment and another fragment. And this, in general, ends up telling me, right? Oh, I didn't do detailed. I did limited. This would also start to give me some insight if I did detailed as to how full those pages are and how fragmented my internal fragmentation is. So far, I just know the left to right external fragmentation. So if we want to get sampled information, a second ago, a lot of these other columns at the end were all null. Now what I can see is the minimum record size, maximum record sizes, average record sizes. So if you have varchar, you'd get some insight. Obviously here I don't have varchar, I have fixed width rows. Right? This particular table has fixed width rows. I'm going to show you some demos in just a second with a table that doesn't have fixed width rows. And then, since I don't have a heap structure, I don't have forwarded rows. I did briefly talk about this in the last session, but if you have a heap, you can also find out how many forwarded records you have now. This is new in 2005. We didn't have really a good way of doing this in 2000. You could interpolate it, but it wasn't direct like this. So, all right, that's my sampled. And then if I want to go detailed, right, I can end up seeing a lot more detail because they've taken all 3 of the levels for each of the indexes and they've expanded them so that I can see my fragmentation at each of the different levels. So the level that you're probably the most interested in, well, it should be fairly obvious maybe from this, is level 0. Level 0, they always build indexes from the leaf level up to a root. So the leaf level is always level 0. Okay, so level 0 is the critical level to be interested in because that, if you have fragmentation in the leaf level, then it's possible you'll have fragmentation all the way up. But to be honest, if you don't have fragmentation at the leaf level, you're very unlikely to have fragmentation all the way up. So checking and analyzing just the leaf level is usually good enough. So you don't really need to go full-blown detailed. And in some cases, you could get away with just that pure limited scan and end up seeing what your fragmentation is and rebuilding solely based on those numbers. So now it's a lightweight, fast way of determining external fragmentation, and then you can fix it. So that's really where we're at, is how do we fix this? So before I do the how do we fix this, I want to show you a script that is kind of a self-paced exercise if you're interested. And it'll kind of prove these points a little bit further, and I really like this particular demo. So this is one that I literally put steps in and a ton of comments in, so you might really enjoy this. But Credit is the database that you can download off my website. It's a simple sample database, the idea being, you know, lots of charges so we can do some interesting things in terms of joins and queries. So I'm going to use Credit, and I'm going to go ahead and build a second table called member2 from the member data, basically so I don't trash the member data. Okay? So just create a separate table. I'm then going to, and is that font size big enough? It's okay, everybody can see that in the back? Okay. So I'm going to alter my table member2, and I'm going to add a primary key that's clustered on the member number, and I'm going to add just 3 non-clustered indexes. Okay, so I'm not even adding that many indexes. Your tables can have up to 249 non-clustered indexes. Not that you should ever go that far at all, right? Usually under 20 is pretty much normal, and even under 10 is probably more likely. And if you're read-only, maybe you'll go above that, but it's rare that people are even well into double digits. Okay, so I'm just putting 4 indexes on, and I did just execute that, didn't I? Let's run it again, see if it fails. Okay, so All right, so now I'm going to check my indexes really quickly. That's not very exciting, but you can see that the indexes are there. I can run a query against sys indexes. I do have this particular query in here. You know what I'll do is I'll also create one just for interest's sake, if you're interested, the right way. Sys indexes is still there, by the way. I know I've mentioned a couple of times these things called catalog views, but what they, and that's now sys.indexes, but not all the columns are going to be the same. So it may not directly run like the, in fact it won't. I know that because ID is no longer ID, it's actually object ID, and in fact in this case it might even be index ID. So I'd probably even have to do a quick look, but I bet one of those columns is going to fail. So let's just do quickly for simplicity. I know I don't like doing star either, but we can just quickly do a quick select star, find out what we're looking for here, index ID and object ID, and that's really what we want. So now, if you wanted to go ahead and select against the old, what was system table, it's now a view. They call it a compatibility view, a view that's there for backward compatibility. And in many cases, it still works. In many cases, it'll probably give you the same information. But for things that have been deprecated or changed, it may return null or different values that you're not expecting. So it's way better to move over to the new catalog views in SQL 2005, which almost always start with a sys.dot. Okay, so sys.indexes. And then we can end up seeing our 4 indexes there against the sys.indexes catalog view. Okay, so there's ways to see the indexes, but that's not the interesting part. Let's do this. So I've had this script in many iterations over the years, so I actually kept in some of the old stuff just as kind of interesting, especially if you're going against 2000. But in older releases, you had to do some really weird stuff with DBCC show-config. In 2000, you can put in the name, and in 2005, we're going to use the DMDB index physical stats for this particular object. So let's check our fragmentation, and it turns out that this was just created. So the average fragmentation is none. The number of fragments is 1, right? And the fragment size is 142 pages. This table structure is completely and totally intact. There's no fragmentation whatsoever. Okay, so that's good. So this would be where we would get the error, and then we would run it again. So we already saw the fragmentation. Okay, so now what I'm going to do very simply is I'm going to modify some data. I'm going to modify the street to be 1, 2, 3, 4 Main Street, the city to be anywhere for columns that are currently variable width and null. So I'm going to make a bunch of the rows larger, wider, updates that are going to cause some form of split. So I do a bunch of other things around it that aren't really that interesting to just find out how long it takes, how many rows I modified, so I can get some performance numbers. Okay? So really the only thing that I'm doing is right here. Updating member 2, set the street for all of the rows where member number mod 19 equals 0. So I'm literally going to modify row 19, 38, 57, 76, and so forth all the way through the entire table. So I will run this, and it's kind of amazingly fast, right? It comes back 526 rows in 126 milliseconds. So for simplicity, I'm going to do this just so that we remember these numbers in one particular place. I'm going to do rows and time. We don't really care much about everything there, but there we go. So I'm going to do rows 526, and the time is 126 milliseconds. And then I'm going to check to see if there's any fragmentation as a result of what I've just done. I mean, 126 milliseconds, how much damage could it have done, right? Well, this is kind of amazing. Index level 0, which, remember, average fragmentation was 0. Now, my table is 83% fragmented. I have 205 fragments of roughly 1.19 pages each. I split almost every other page. So now I am wasting space, especially if we look at the average page space utilization, right? Because this is saying that the pages are on average only 57% full. So now I have split all of this, spread it out. I'm only filling roughly 57% of each of those pages, and that caused that insert to be slower, and now it's wasting space, and my queries are going to take longer because I'm now reading a lot of blank space, per se, into memory, wasted space into memory. So now, how do we fix this? Well, I'm about to go back to lecture here, but there's a huge section of comments. So this will help you review a lot of what we're talking about here today. In fact, 7 is all comments. And then 8, okay, more comments. And then we get to the very end. We want to do some form of rebuild. And I'm going to go through this syntax in a second. Let's say I want to show you the end result first. This will make you be more attentive for the rest of this. But if I alter the index on this table and I rebuild it such that it builds it to a fill factor of 90%, so it's not going to fill all the pages 100% full, which is the default. It's going to instead fill each page to 90%. So each page will be 90% full, leaving roughly 800 bytes available on each of those pages. And I'll tell you a little bit more on why I chose that particular option. But let's check our fragmentation again. And I will scroll over. There is no fragmentation because it's been rebuilt. Okay. There's a little bit of fragmentation. They couldn't allocate the entire table in one chunk of the database. So there's actually 2 fragments to it. I'm not really worried about that. The average fragment size is half the table, and it's probably more than that. It's an average, so it's probably very skewed. It might be the bulk of the table and then one other page or a couple of pages. So I'm not worried about this at all. Okay. And if we look at our page space utilization, 90%, which is what we asked for. So now I go back and I run another modification. This time I'm going to modify where member number mod 17 equals 0. And the thing that's kind of amazing, well, 2 things, is I modified 588 rows, but look at the time as well. So I modified 10% more rows in less than half the time. That's kind of cool in and of itself. It's a small data set, but it still proves a point that without the splits, your inserts and your updates, if they have enough room, are going to be faster. Because the splits are going to cost you on the split. Not only in the fragmentation, but in the time for the insert or the update. So you're getting better performance for your insert and update, and then let's look at what happened to the table. Now, it's a little bit of a contrived example because I'm very evenly distributing my updates. So it turns out that in this case, I still have no fragmentation. I really haven't changed anything of the table. The only thing that's changed is the amount that the pages are full. They were 90.11. Now they're 90.95. So I'm slowly creeping up on the amount of space I'm filling within those pages. So then the next question usually is how long does this last? Well, with perfectly evenly distributed data modifications like what I'm doing, it's going to last a while. In the real world, you might have more modifications in one area, and you might see some splits. But the end result is that you're really putting off these splits from happening right away by leaving this free space. So let's bring all this together here. I definitely like the DMV. Okay? I like the DMV to see the information, but really what we want to do is use the DMV programmatically. And we want to end up putting that data into a temp table, walking that data set, and then if the fragmentation is greater than some amount, we may want to do some form of reorganization to that table. And I mentioned that down here. I've been showing a rebuild in terms of my reorganization, but there's really other options. There's a rebuild or a defrag. And the recommendations in general are that you should rebuild if you have a lot of fragmentation. And if you just have a little bit, then you'll probably just want to defrag. But if you can't do an online rebuild, then you may end up having to defrag more frequently. So that's really the next question is, what are some of the restrictions on how this works and when we can do this? So external versus internal, we can see all of these in the DMDB index physical stats. I still have trouble saying that exactly right, but average fragmentation in percent, fragment count, and average fragmentation size. So these are some of the values you're going to look for to see if you have fragmentation. And of course, internal fragmentation is based on the bytes that are free and the fullness of the pages. Okay, so that's fairly straightforward. So then, rebuilding, defragging, what are the differences? A rebuild, which is actually what I recommend in general, is a complete pick up the table, copy it, and restructure that entire table for, well, better logical grouping. Because if they can grab a fully contiguous chunk, they will. So if you have lots of fragments, they pick up that whole thing and hopefully grab a nice contiguous chunk and put that table there. So you'll have a lot less extent fragmentation as well. Defragging is not as exhaustive. It actually works through your table in little mini chunks, just kind of moving data over between the pages in the doubly linked list to make the doubly linked list left to right. So if the doubly linked list right now goes here to here to here, what they'll end up doing in a defrag is they will go to the first page, right, and then they'll take the next page and kind of move it off, go to this page way over here and move it over. So that it turns out that they've got A's and then more A's and then B's and then C's. But if there's lots of gaps, the gaps don't get cleaned up, meaning they just fix the left to right order. But it works in little tiny mini transactions. So it never really directly impacts your availability. They fix a few things, let go. 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 So that's very lightweight in terms of availability. It doesn't impact your availability. Rebuilding may not impact your availability either, because rebuilding does now support what's called an online rebuild. So let's talk about this. I do recommend rebuilding over defragging, okay, definitely. And you've got a couple of options for this. If it has to be done offline, and there are some requirements, then that's going to require locks, which is downtime. The ways that you can do this, some of which are always offline, you have to be aware of. If you use the old commands, it's always offline. You only get online rebuilds if you switch to the new syntax and the new commands. So the new syntax and the new commands for rebuilding an index are alter index rebuild. What a concept. You mean it's not dbcc db reindex anymore? Right? This actually makes sense, and that's what they were trying to do across the board, is make things make more logical sense in terms of those manipulation and operation steps. So alter index rebuild, and you actually have an option to go with offline or online. The default being offline, but online, if you can achieve it, is preferred. dbcc db reindex. The reason why that's nice that that's there is if you've already automated this process, all of your automation scripts won't break. Okay, so you can continue running them today, but you'll get the same behavior that you had in 2000, meaning offline rebuilds. Create with drop existing, you know, I don't tend to see that except for like one-time changes to the clustering keys, so I'm not going to worry as much about that. 90% of the people out there that have automated this are using dbcc db reindex, and then what you'll want to do is switch over to that in 2005. Now, defragging doesn't completely remove all your levels of fragmentation, but it's always online. Very lightweight to your availability, but it doesn't update statistics. When you rebuild, they pick up the whole object, move it, and restructure it, and they read all the data, generating statistics. Statistics are what the optimizer uses to know information about your data, to do a better job at optimizing the queries that run against that data. It is a good thing to have statistics that are up to date and accurate. If you end up only defragging, then you will also want to do some form of update statistics to get your statistics up to date, which is why it's better to go with a rebuild than a defrag. Alter index reorg is the new syntax. dbcc index defrag is there for backward compatibility. There are some changes internally in how it works, but conceptually it's still exactly the same. Now, the way that you're going to minimize this fragmentation is by doing what I did. When you do the rebuild, you add some level of free space that spreads that data out a little bit, not so much that you've basically doubled your table size and you're wasting half that space, but spread it out a little bit so that there's enough room to kind of survive until it needs to be rebuilt again. Because this is not a one-time process. As data keeps coming in, you'll rebuild again. Data keeps coming in, you'll rebuild again, and you'll automate all of this. You'll run this daily, weekly, monthly. So you'll add some free space when you do a rebuild, and that free space will be something called a fill factor. Now, that's a good question. How do we set and decide what our fill factor should be? Fill factor is how full those pages should be. And is there a magic number for this? No. Okay? It's really based on how frequently you're going to rebuild and how much data comes in that causes fragmentation. If you have a spattering of inserts and updates and deletes, it's not a real volatile table, and your availability requirements are not 24/7 by 365, you might be able to rebuild nightly with a fill factor of like 95%, right? But if you have a lot of data coming in and you can't rebuild very often, you might have to go with a lower fill factor. So I have some guidelines that you can end up using to kind of help you. What's causing splits? Is it inserts? Is it updates? Because inserts need more room, so inserts probably need less fullness, right? They need to be more empty space, a lower fill factor. And how often can you rebuild? Because that's really the question that's going to answer it the most. The more frequently you can rebuild, the higher your fill factor. Now, you're not going to be right. I mean, it's just very hard to be right on this because it's always based on the data access patterns of the data, the database, and the users, and how the data is changing. So you test your estimate by checking your fragmentation. If you rebuild it on a Sunday and you check it Monday afternoon and it's still 0, no fragmentation, your fill factor might have been fine. I might argue maybe it's too low. If you're going to rebuild on Saturday and you keep checking it every day and then Friday it's still 0, then I would check your average fullness for the pages. And if your pages are only 87% full because you used a fill factor of 80, I might argue you could probably get away with 90. You're not going to have to do this every day of every week of every month, but do this for a week or two while that data starts stabilizing in production to get the exact numbers. And you can certainly make some guesstimates in development by knowing even just a little bit about your access patterns. And what most people end up doing is they create a little table with a whole bunch of the numbers that says this table should be rebuilt when the fragmentation hits this, and it should be rebuilt on Tuesdays. And they create a little table that they walk through every night for which tables to check and then what to do if they hit certain thresholds. It becomes very easy to do, really. And in fact, I've already written some code to help you do that. But why, when, and how? And I think we've kind of got some of the answers to this. Why do we want to do this? Better performance, minimizing the cache requirements, minimizing the speed at which the inserts, updates, and deletes take because we won't have splits. Improve the read performance because the tables are going to be more condensed, more compacted, and as a result, we'll have a lot less resources required. Now, when depends on the table. The more volatile, the more frequently you're going to try to do this. The less volatile, the less you'll need to do this. Okay? And of course, you always have to look at the impact to availability. So that's really the thing to be a little bit aware of here is in SQL 2000, everything was offline. In SQL 2005, the alter index rebuild replaces the old commands and has an option, it's a mode, of being online. But before we can do that, we have to determine if we can rebuild online. Now, this is the syntax for it. Okay, with online equals on and fill factor of 90. Okay, so you basically use this parameter to say that you want it online. If it can't be rebuilt online, they'll squawk at you with an error that says, hey, you can't rebuild this online because of whatever rule you did not meet, right? Whatever your problem was. In this case, notice the error. Online index operation cannot be performed for index member ident because it contains a column photograph of data type text, ntext, image, varchar max, nvarchar max, var binary max, or XML. Okay. This is a design best practice that I really want to stress. If your table, or let's make it different, if your index at the leaf level of your index, which means the clustered index is the data at the leaf level. For a non-clustered index, you can have lob data in the leaf level now in SQL 2005 with something called an include. If in your leaf level of your index there is lob data, that index cannot be rebuilt online. So if I have a table that is really critical and I have lob data in it, then I really have two parts to that data. I've got probably the OLTP data set, but then I've also got the lob data. But putting that in the same table will remove all capabilities for rebuilding that clustered index online. What am I recommending in a lot of cases? Vertically partitioning some of your lob types from your tables to go into a separate table so the non-lob types are in a structure which can be rebuilt online, and the lob types are in a structure which is separate. Now, some of you might be going, well, why does that matter? They actually do something called lob compaction now, which is great, actually. If any of you guys had fragmentation in your lob data, there was no way to really get rid of it prior to SQL 2005. And in SQL 2005, lob compaction is automatic. So the thing that you have to be really careful of is, do you want the lob compaction to occur when the table is being rebuilt? And it will no matter what by default. So instead, you may want to partition so that you don't get impacted by that lob compaction. So now you have two tables, one with the non-lob, one with the lob, and that you can rebuild offline, but this you can rebuild online. And I list the lob types there. Partitions that are partitioned of a partition table cannot be rebuilt individually online, but the entire partitioned tables index can be rebuilt online. So that's a little bit of an interesting limitation. I'm hoping that one will get changed fairly soon, but maybe not in IUCon. So anyway, so these are some of the restrictions. Disabled indexes can't be rebuilt online. I haven't talked about disabled yet, but let me do lob compaction, then I've got disabled, and I'm pretty much just about to wrap up here. But offline lob compaction, I did put, if you're interested, a really long blog entry on Wednesday, August 25th, 2004, on how to compact blobs in SQL 2000. If you really want to know how to do that, it's a little bit painful, but you can. In 2005, it's automatic. So I mean, I do like that new feature, but I don't want it to negatively impact my base table's non-lob types. So how did the online index operations work? Let's take a second on that. And then I do have a slide on disabled. But how do they work? How can they rebuild this structure online? Well, the way that it worked before is they took that object, they picked it up, they copied it, and they rebuilt it, and they locked it to make sure that it was accurate. But you still had two copies of the index in the interim, right? So now, in 2005, the two copies are actually used in a dual mode update process, meaning the optimizer and the users still go against the source, the original index, while the online index operation is rebuilding the target index. And all updates are going to both indexes at the same time. Is this expensive? Yes. But I will take all of my operations to be slower for 10 minutes than no operations at all for 5 minutes. It's a very easy choice. If you can have all of the manipulation continue while it's being rebuilt, I don't really care that it takes a little bit longer. Okay? So there's a nice diagram. This came straight from the books online, so I'd highly recommend reading the section in the books online called How Online Index Operations Work. And it kind of talks about the fact that there's a phase where they don't allow any activity. I know I just said it was online. This phase is really, really short. It's basically a synchronization of metadata, making sure that the metadata doesn't change. So it's a quick, okay, do I know what the metadata structures are? Yes, okay, now I can go from there. Users are back in. Selects are going against the source index. The target index is write only internally for the index build. At the very end, the optimizer has to be made aware of the new index, and the old index has to be dropped. So again, there's a freeze. Let the optimizer know about the new index, drop the original, and then it goes on. So you're looking at really small impacts to availability, seconds, right, at the beginning and the end. And second is probably more like it. So in Profiler, if any of you use Profiler, which I'm hoping you do, there is now a index progress report for the rebuild, so you can kind of see where it's at. I took a small scaled down build for this one, but over on the far right there is the number of rows that we are at. So here it's essentially keeping track of what row number it's at. So it's a progress report in the various stages of the rebuild, and the really big step is the kind of copying over of all that data. So if you have millions and millions of rows, this would have produced many, many, many rows. It's usually every 5 to 10,000 rows they'll give you a status. Okay? All right, so some special considerations for online. The current activity is impacted just slightly at the beginning, just slightly at the end. Your performance is impacted. Changing from a heap to a clustered is the most expensive because the structures are actually different. So they have to create this internal mapping index that kind of helps them know where the data sets are. So I'm just saying that's a little more expensive, but again, it's still online. Again, I don't care if it's more expensive if I can do this online. And you can only do one at a time. So that's another restriction. Now, this whole disabled concept, I do want to give you some insight. Yeah, there we go. One more slide. So a couple of So a couple of tips. I'm like 3 slides away, really, but index rebuild tips. If you want better availability, partitioning, vertically partitioning, as I mentioned. Now this is a cool one, and this one kind of has to do with the disabling, right? If you want to disable a non-clustered index, what you're doing when you disable a non-clustered is you keep the metadata, but you get rid of the data. You get rid of the index itself. Then all you have to do is say that you want to rebuild the non-clustered, and that can be online, meaning the base table can still be modified while this index is being created. So you end up not having to have both structures for the entire time that it's rebuilt. So you can save some space and increase or decrease the amount of time that it takes to actually run your rebuild. Okay? So keeping your table online, though, don't disable your clustered index. That's a common misconception. Disabling non-clusters makes sense, but not the clustered. Okay, so disabling an index, to summarize that, it prevents all access to the index. But for non-clustered, this can be really useful to disable the non-clustered, but still allow the table to be accessible. Okay? A disabled index can be rebuilt or dropped, but nothing else. There's no way to re-enable it. Re-enabling it is rebuilding it. Okay? And DBCC, CheckDB, and index defrag don't work with disabled, but the alter index does. Okay. Now, there's a weird thing that is a side effect of disabling. If it's a key index, your foreign keys get disabled and have to be manually re-enabled. So I would be very hesitant to disable key indexes. So be a little bit aware of that. Okay? Now, this last really concept here, what I would do if you want to automate your index rebuilds, use some form of loop and cursor to walk through all those tables that you've gone and populated into a temp table, programmatically determine if you have any fragmentation, and rebuild only those with the fragmentation level that you desire. And in fact, I've already done this. Okay, this is essentially a stored procedure called SP rebuild indexes. So SP rebuild indexes, scan density 80, says rebuild all of the indexes. Now I'm using kind of the old term, but the concept is the same. If the indexes do not scan better than 80%, so they have more than 20% fragmentation, then go ahead and rebuild them. So it'll go through and only rebuild those that have a scan density less than 80. I'm in master, so there's really nothing exciting there. Let's do all indexes, and what I'll do is wrap up the slides. Did I already rebuild everything? So there's nothing that's fragmented, which is a bummer. But create a procedure, set up a job. Okay. Now, I did this as an if time permits. I have exactly 5:45 right now, so I don't really have time for this. I do want to mention Gert Draper's session on DMVs. I thought I might have some extra time. So you do have some good slides in here to review. I put some good details on DMVs. But remember I was talking about this whole DM object interface? If you want to find out a little bit more detail, there's all these different groupings. And I have a couple of queries that will help you to start figuring out what the DMVs are. Sys.system objects for all the DM%, right? Well, the underscore is a wildcard as well, but DM%. And then I've got some functions inside of a little script that will help you interrogate better what those DMVs are by telling you if it's a function and what the input parameters are and what the output data set is. Okay? Index-related DMVs, index physical stats, operational stats, usage stats. This tells you whether or not your indexes are being used. However, it is reset when an index is rebuilt. So be aware of that. You may want to take this information and, let's say nightly before you do your rebuilds, put it off into a temporary or maybe a permanent structure that you create with the date and time it was run, and then you can see trends over the course of a month of whether or not your indexes are being used. Partition statistics. There's actually query stats. You're going to love this. It tells you the number of times queries were executed, the first and last execution times, right? The number of times that something gets recompiled, the min, max, average, and last for execution, physical reads, writes, logical reads and writes. It's unbelievable how much detail you can now get from the server of what's going on. That's it for me. I'll stick around for questions, and thank you very much.